Science.
Each morning, marine biologist Lars Brunner dons his wellies and wades into freezing Scottish waters, all in the name of biofuels. Collecting different specimens of algae, he then returns to his offices in Oban, where he carries out tests to find out which seaweeds potentially produce the most fuel in the shortest amount of time.
We don't advocate large-scale extraction of the wild product ourselves. What we are interested in is actually trying to perfect cultivating it, taking some wild specimens to use the seed, but then actually growing it on long line systems in a way you would use, for instance, to grow mussels.
As algae lacks lignin and has a low cellulose content, its capacity to biodegrade into methane makes it a far better material than many plants found on land. Verification takes place at the lab, where scientists use the latest techniques to test the properties of each algae sample. Here, once the specimen's molecular makeup has been identified, they're archived into the largest living library of algae in Europe. Using specialised machines, they measure the different components, looking out for fatty acids, which are the primary ingredient for turning algae into biofuel. In doing this, the researchers can determine how much fuel can be made from each individual species.
When we say algae, that's both microalgae, so the small single-cell organisms, right the way up to seaweeds. So in terms of microalgae, there's interest in biodiesel production, and in terms of the seaweed, we're looking at biomethane and bioethanol.
Microalgae, which naturally produce oils, convert solar energy more efficiently than terrestrial plants. Large brown macroalgae, or seaweed as it's commonly known, grows exceptionally well in coastal areas and can be readily used as biofuel. Both macroalgae and microalgae have the potential to be used as biofuels, so could they provide a sustainable energy solution? We go now to decidedly warmer climes in Australia's capital Canberra, where algae is creating some big problems. Here at Lake Burley-Griffin, the presence of toxic algae clogs up the popular tourist attraction, forcing it to close for days on end. But new solar energy technology could help the authorities with their water cleaning woes. In an attempt to battle the blockages, they've created 2 solar-powered circulators, which stir the water and stop any algae forming. The 5-metre units float on the surface of the water at 2 separate sides of the lake as part of a 3-year trial. Scientists will continually monitor the levels of algae in the treated areas, then compare the data with amounts found in the rest of the lake. If successful, 5 more circulators will be installed across the entire length of the lake.
We've got floating circulators that look a little bit like a satellite that's landed on the lake. It has a dish that contains the pump, and it's supported by 3 floating arms, and they sit just at water level on the lake and draw water up from beneath and circulate it.
In a bid to attract major sporting events, Canberra's considering extending the experiment to other lakes. So is algae the fuel of the future, or an expensive annoyance? One thing's for sure, there's a lot more to this sticky green substance than first meets the eye.